Happy day to all. Today we are going to see UGC NET previous year questions in Discrete Structure subject part 2. This is the part 2 video. Yes, the first question is, if n and odd are non-negative integers and n is greater than odd, then p of n plus 1 or equals to what? So normally what is p of n comma or, that is NPR is, we are defining as n factorial divided by n minus or factorial, right? So in this place we have to apply the n in the place of n plus 1. So n plus 1 factorial divided by this n is called as an n plus 1 minus or. So if you apply, what is the answer is n of or n plus 1. So this is nothing but option A. So option A is the correct answer. The next question is, a graph is a non-planar if and only if it contains a subgraph homeomorphism. Subgraph homeomorphism, then which one is? Graph is a non-planar, okay, K3, 3 and K or K5. So this is just a statement. You have to remember that a graph is a non-planar if and only if it contains a subgraph homeomorphism to K of 3, 3 or K5. So that means K3, 3 means, see, three vertices and here also bipartite, right? So if connected like this, so this will be surely a non-planar graph because we are not able to draw the without intersecting the edges. Without intersecting, if you are drawing without intersecting the edges, then it is called planar graph. So in this graph you are not able to draw without intersecting the edges. So that is non-planar graph. So K of 3 or K of 5, 1, 2, 3, 4, 5. So if this is connected like this, okay, this star, okay, this in a complete graph, okay, and this is also an non-planar graph, okay. So K of 3, 3 or K5 is the non-planar. The next question is, a dash complete subgraph and a dash subset of vertices of a graph G, V, E or click Q and vertex cover respectively. So a maximal complete subgraph, so maximal complete subgraph and a minimal subset of vertices. Okay, what is click Q means? For example, consider this graph, okay. So this is A and this is B and this is C and this is D and this is E. Okay, click Q means, so we can take it out, this one. So A, B, C, and then we can also draw A, C, D, okay, and then we can also do this B, C, E and this. So we can split this. This is called as a complete subgraph. This is called click use. See, without we cannot sorry, we cannot split more than this, okay. So this is A, B, C. More than this we cannot do a subgraph inside, okay. So this is called a complete subgraph. See, A, B, D is also a subgraph, but a click Q is a complete subgraph, and this is called, first of all we will see click Q. So this is click Q, okay. So this is maximum complete subgraph. So after that you cannot find. So maximal complete subgraph and a minimal subset of vertices. So I am seeing, see, A, B, C, D is also, but I am seeing the minimum subset of vertices. So A, B, C, okay, this is a minimal subset of vertices of a graph G equal to V, E. This is called as a click Q and a vertex cover. So complete, maximal complete subgraph and a minimal subset of vertices, maximal minimum subset. So that is option D. A maximal complete subgraph and a minimal subset of vertices of a graph G equal to V, E or a click U and a vertex cover respectively. The next question is, consider the graph given below. So consider this graph. Which one of the following graph is isomorphic to this above graph? So which of the following is an isomorphic to this above graph? See, U1, U4, U6, U7. So if you draw like this, see, 3 edges are there. So 1, 2, 3 must be there. See, here it is 4. So you can remove it. So this edge contains, see, 1, 2, 3, 4, 4 degree. But here all the vertices having only 3, right? So you can remove this, you can remove this. See, you can remove this. So option C is the correct answer. See, isomorphic means the number of edges should be equal. See, for this graph and this graph should be equal. Number of edges should be equal. And number of vertices should be equal. Number of vertices should be equal. And the cycle length should be equal. Between the two graphs. So this is one graph and this is one graph. I am telling that this graph is isomorphic to this graph. When I can say this graph is an isomorphic to this this graph. So if there are equal number of edges present in between these two graphs, and equal number of vertices should be present, and equal number of cycle length should be present. Okay. So based on that, I am telling that C is the option. See, here in all the vertices have degree 3. So if there are only one vertex is degree 4, we can remove that option. Okay. So based on that, I am removing option A and B. See, here also 4 degrees are there, right? For V3, 1, 2, 3, 4. So this is not an isomorphic graph. Whereas V1 is having only 3 degree, right? It may be anything. It may be represented in any form, but this should be equal. Number of edges should be equal, number of vertices should be equal, and cycle length should be equal. Then we can say that two graphs are isomorphic graph. Hope you clear? Yes. The next question is, how many cards must be chosen from a deck to guarantee that at least 2 asses of 2 kinds are chosen? Okay, so how many cards are there? So if you don't know about cards, you just take a cards and check it out. Okay, so there are totally 52 cards are there. Okay, there are totally 52 cards are there. And so from then it is represented in 4 shapes. Okay, one is autumn, one is diamond and claver. Okay, and another one is some shape. Okay, so this will have 13 cards, and this shape is having 13 cards, and this having spade having 13 cards, right? So I am asking, they are asking 2 asses. I want 2 asses of 2 kinds are chosen. Okay, if I want this, how many cards I have to take? So there are totally 52 cards. So if I take 50 cards, surely there will be 2 as and 2 kinds are chosen. Okay, because there are totally 22. So there will be 4 asses. So only 2 cards you are lefting. So if you are taking 50 cards, so absolutely you are having 2 asses of 2 kinds. So if you are not clear, you take a cards, play cards. Just take a play cards. Just count it. It will be 52 cards. Okay. Then think 2 asses of 2 kinds are chosen. If I want 2 asses in your hand, okay, how many cards you have to take? Surely you will get. Okay, you take 50 cards. Okay. So if you take 50 cards, what will happen? Surely you have 2 asses in your hands. Right. So in the same way, 2 asses are chosen. If I want 2 asses, so that is also probability is 50 cards. If you take from 52, if you are taking 50 cards, surely you will getting 2 asses. The next one is 2 cards of the same kind are chosen. 2 cards of the same kind are chosen. That means that is A2 13. So, okay, A 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and J, Q, K. Okay. If I take another chord, that will be same A or 2 or 3 or 4 it will come. So, at that time it will be matched with any one of the above chords. So, if I take 14 chords, surely you place the play cards there, okay. Take 14 cards, surely there you can see 2 chords of the same kind. You can able to see that 2 chords of the same kind will be chosen. The next one is 2 chords of 2 different kinds are chosen. 2 chords of 2 different kinds, that is A. So, the next question is 2 chords of 2 different kinds are chosen. For example, I have to take 2 different chords. Okay, if I want to take 2 different chords, for example, I am taking first chord will be the as. Okay, I am taking second chord is as diamond and third one is as claver. So, all these 3 and again I am taking as spade. Okay, so 4 chords will be same, but if I take one more chord, what will happen? Either it may be 2 or 3 or 4 will come. So, 2 different kinds of chords will come at that time. So, if I take 5 chords, I will get surely 2 chords of 2 different kind. Okay, 2 chords of 2 different kind is chosen. So, option A, 50, 50, 14, 5 is the answer. The next question is, consider a complete bifacial graph K, M, N for which values of M and N does this. Complete graph have a Hamiltonian circuit. Complete graph have an Hamiltonian circuit. So, for this M and N should be greater than or equal to 2. Okay, then only you can able to do the complete bifacial graph. Yes. The next important question is this one, the average length. Optimal coding technique will have the average. Okay, let's see. A text is made up of the character alpha, beta, gamma and omega and this with the probability 0.12, 0.40, 0.4. So, that is probability means this particular letter is coming 12 times for 100. Okay, this letter is coming for 40% like that. So, they are giving some points, probability points 0.12, 0.40 and 15, 0.08 and 0.25 respectively. The optimal coding technique will have the average length of. The optimal coding lengthing will have the average length of. So, to do this, first write down this for this question, sometimes it is difficult to remember this, write down this alpha and beta, gamma. No, you can just assign for alpha as A and for beta as B and for gamma as C and something this tau as D and omega as E. Okay. So, now A value is 0.12, B value is 0.40, 0.15 and 0.8 respectively. So, to find out the optimal coding length, first take minimum two values. What is the minimum 2 value? 0.08. Okay. So, write down this in left side 0.08 and the next value is 0.12. Okay, 0.08 is one value and 0.12 is another value. Okay, when you add, you will get 0.20. Okay, what is this? This is 0.08. Write down this is D value and this one is A value. Okay, first take the 2 small values, write down the small value in the left side, write down the next small value as 0.12. Okay, now you take this remove this. Okay, now consider this values 0.40, 0.15, 0.20 and 0.25. Now you do ascending order. So 0.15 and 0.20. So 0.15 will come to the left of 0.20. Okay. Write down like this. 0.15 is a C value, right? So write down this. And what is the addition? 0.35. Okay, so 0.15 is finished. Now what is the value is 0.25, 0.35. At the root you have to consider 0.25 and 0.35 and 0.40. Which one is smaller? 0.25. So that must be come to the left of this. Okay, that should be come to the left of this. So 0.25 plus 0.35 is 0.60. Okay, so 0.60 and then now 0.40. 0.40 will come to the left of this. 1.00. Okay, so that's all. So now you have to write down, if it is in a left side you have to write 0. If it is in the right side, write 1. Okay, right side and all you have to write the 1 and left side you should draw as 0. Understood? So this is what? E, and this is B, and this is C, and this is D and A. So now we have to write the code length for A. Code length for A is here always the root should be 1.00. Okay. So A value, A coding length is 1, 1, 1, 1, 1, 1, 1. Okay. And for B value is 0. B value is nothing, 0 here in this place. Okay. And then C is this 1, 1 and 0. So C value is 1, 1, 0. And D is 1, 1, 1 again then 0. 1, 1, 1, 0. Then E is 1, 0. E is 1, 0. So now you have to multiply this into that coding value 0.12. So for A is the value is 4 into 0.12. Okay, 0 into 0.40. Sorry, 4 not, sorry. That is 1 bit. How many bits are there in A? 4 bits. So I have to write 4 into 0.12. So in a B there are 1 bit. So write down 1. So in a C there are 3 bits into 0.15. In a D how many bits? 0.08. Okay, this is 4 bits. D is write down then 0.08 and for E is 2 bits and that should be multiplied with 0.25. That is equal to 0.50 and this is 8 4s are 32.32 and 0.45 and this is equal to 0.40, 0.48. So when you add all these things, 8 plus 10, 15, 5, remainder 1, 9, 13, 13 plus 8, 21. So 2.15 is the answer which is available in the option B. So the answer is B, 2.15. The optimal coding length will have the average length of 2.14. Okay. Yes. The next question is, given the following statement, the subgraph is isomorphic problem takes two graphs G1 and G2 and ask whether G1 is a subgraph of G2. Subgraph isomorphism problem takes two graphs G1 and G2 and ask whether G1 is a subgraph of G2. And so we can able to, so in this, the second statement is also the set partition problem. Take as input a set of numbers and ask whether the number can be partitioned into two sets. Okay. So first of all we have to remember NP and P. NP means non-polynomial time. Non-polynomial means we don't know when it's completed. Okay. For example, count 1 to 5. If I am asking count 1 to 5 means 1, 2, 3, 4, 5. Okay. So within 5 seconds, my job is completed. That is a polynomial time. That is P. P means polynomial time. My job is completed within a specified time. Okay. My job is completed within a specified time. It's called as a polynomial problem. And my job is not completed. It is called as a non-polynomial problem. Okay, for example, if I want to count 1 to infinitive, I am not able to count 1 to infinitive, right? So it is going on. So when I am splitting, it's going on, right? So that's called as an NP problem. So as per this, they are telling that S1 is also a non-polynomial problem and S2 is a non-polynomial problem. So S1 is a non-polynomial problem and S2 is a non-polynomial problem. The next question is, consider a set 1, 2, 3 up to 1000. How many members of A shall be divisible by 3 or 5, or they are giving, or remember this word, or is different by and is different. 3 or 5 or by both 3 and 5. 3 and 5 means nothing, 15. If a number must be divided by 3 and also 5, that means it must be divided by 3 and 5 means, that is, it must be divided by 15. So 75 will be divided by 3 also and 5 also. Then it must be divided by 15. Okay. Yes, now we have to check it out. 1000. So there are totally 1000 numbers. First, divisible by 3. So divisible by 3 is 1000 divided by 3 equal to 333. Okay. And divisible by 5. So 1000 divided by 5, that is equal to 200. And so totally there are 533. Okay. By both 3 and 5. So both 3 and 5 means it. So see, here we are getting how many numbers divided by 3. So if here I counted how many numbers divided by 5. So this must be divided by 15 also. So I am subtracting 3 and 5. So 15, 3 and 5 means 15. So number of values divided by 15 is what? 1 5 so 5. So when you divide this, so 66. Okay. So we have to subtract from this to this, because they are asking 3 or 5. Okay. 5. So I am subtracting this, how many numbers which are divisible by 15. So when you subtract 7, 6, 12 minus 6, and 467. So 467 is the answer. Okay. The next question is, a certain tree has 2 vertices of degree 4 and 1 vertex of degree 3 and 1 vertex of degree 2. If the other vertex have degree 1, how many vertices are there in the graph? So certain tree. Okay. Tree, this is a tree. Okay. So the tree must be contains edges must be contained, number of nodes minus 1. Okay. Because in a tree there should not be cycle also. So 2 vertices. Okay. 2 vertices, degree is 4. 1 vertex of degree is 3 and 1 vertex of degree 2. And if the other vertices, I don't know how many vertices are there. So they are telling that the other vertices, okay, consider total vertex x. X means, so this must be x minus 4. So x minus 4 vertices have the degree 1. Okay. how many vertices are there in the graph? How many vertices are there in the graph? So as per the handshaking theorem, what handshaking theorem says? Sum of degree of vertices is equal to 2 into edges. Sum of degree of vertices equal to 2 into edges. So what is the degree of vertices? We will just count it. 4 plus 3 plus 2 plus x minus 4 into 1. We don't know how many vertices, right? So if the remaining vertices are, consider this 10. So 10 degree will be there, 10 into 1, because they are telling that all the remaining vertices have degree 1. Okay, so what will happen? So this is nothing but plus, for this, x minus 4, I am writing down, that is equal to 2 into edges. So 2 edges. Edges will be called as total number of vertices minus 1. Total, as it is a tree, so I can say that 2x minus 1. Okay, so in the place of edges, I can replace it as x minus 1. So now you solve this equation. 4 plus 3, 7, 7 plus 2, 9, and 9 minus 4, 5, right? 5 plus x equal to 2x minus 2. So if you take this side, 2 will this side, and x equal to, and x, if you take this 2 this side, 5 plus 2, 7. If you take this x this side, 2x minus x equal to x. So x value equal to 7. So x is what I consider total vertices. How many vertices are there in the graph? So 7 vertices. See, they can also ask what is the remaining vertices also. So there are totally 7 vertices. So the remaining vertices are 2, 3, 4. At that time it will 3. Okay, that time it will be, so very careful in this. They may ask how many total vertices are there, or they can also ask how many remaining vertices are there. So remember this. Okay. So in this we found out that x equal to 7. Okay, so x equal to 7 we found out that remaining vertices are. So already how many vertices are there? 2, 3, 4. Okay, so 2, 3, 4, that is 4 vertices are there already. So 7 plus 4, that is equal to, total vertices is D, option D, 11 vertices. Okay. Consider the graph shown below. This graph is a complete graph? No. So all the vertices, a vertex should be connected with all other remaining vertices. So A is not connected with C, right? So it is not a complete graph, and it is also not a bifurcate graph, because so then all the above won't come. Okay, bifurcate, then this is an Hamiltonian graph. Bifurcate graph means if there is no connection between the same set. Okay, how to say? See, bifurcate graph means if this is A and this is B. Okay, so A is connected with B. Okay, and A should not, if C is the vertex, and this vertex should not connect with A. Okay, so then only we can say that it's a bifurcate graph. So this we cannot say this bifurcate graph. To find out whether it is a bifurcate graph or not, we have to, I will tell you. So to find out whether the given graph is bifurcate graph or not, we have to give 2 colors. Okay, I am taking now green. Okay, this is red, right? So another this should be green. This should be green, and this should be green, and this should be green. Okay, and this, see, in this green should not connect with green, right? green color should not connect with green color. So this is another, and this is another, and this is another, and this is another. So all the connected graph. Okay, this is another set. Okay, this is the another set of graph. So within this set, the connection should not present. Okay, if I am telling A, this is B, F, E, D. So A connected with B, F, E, D. But B should not connect with F or E or D. Then it is not a bifaciate graph. Then this is not a bifaciate graph. Understood? Yes. So it is not a bifaciate. So Hamiltonian graph, what is Hamiltonian graph? If there is any cycle formed within the graph. So if there is a cycle, there is a path, yes. So from A to D, I can traverse all the vertices. So there is a cycle where we can traverse all the vertices without repeating the edges or vertices. So cycle without repeating the edges or vertices. Okay, cycle without repeating the edges or vertices, then it is called as an Hamiltonian graph. So the next question I am not aware, so just check it out, but the option is 0.63211. The next question is, if we define the function f, g and h that map r into r by f of x equal to x4 and g of x equal to, this is x power 4, okay, f of x equal to x power 4, g of x equal to root of x square plus 1, h of x equal to x square plus 72. Then the value of the composite function h of g of f. So first find out h of g of f. Okay, g of f means what? In the g we have to assign the x. So what is the d? X square plus 1. In this place of x, okay, in this place of x, I have to assign the f value. Okay, x power 4. Okay, x power 4 plus 1. So this is x power 8. So x power 8 plus 1. This root can be represented as what? 1 by 2, or you just hold it. Okay, just root. Okay, this is the value. Okay, this is the x. Okay, now the next step is h of this. So I am assigning in this h this value. Okay, here it is an x square. So when you do square h of this, okay, this square will be removed. Understood? So when you do square root, this square root will be removed. So the value of h of x is x square. So this is x plus 72, right? When you do this, what happen? The square will be removed, x power 8 plus 1 plus this 72. So the value is x power 8 plus 73. X power 8 plus 73. So which is available in the option D, x power 8 plus 73. And also you have to check it out, g of h. Now we found what? H of g of f. So in the same way I have to do h of gf. So first I have to, in h, x square plus 72, I have to apply g value here. X square plus 1, the root of x square plus 1, the whole square plus 72. So what happens? This will be removed, x square plus 73 will come, right? So if you apply again to this f, so this is called as an x power 4. So you will get x power 8 plus 73. Okay, because the 4 will be assigned only to the x, right? So x power 4 and this 2. So x power 8 plus 73. So h of g of f and h of g and then f. So just remember, g of f means first you write down this g of x and inside you have to, this x of 4 we have to give. Okay. If f of g means in the f, inside you have to give the g of x value to only to the x value. Okay. So be very careful and work out all those problems, then you will be very clear. The next question is, how many strings of 5 digits have the property that the sum of their digit is 7? Okay, I don't know what are the digits. You consider a plus b plus c plus d plus e. There are some of the 5 digits have the property and sum of their digit is 7. And sum of their digit is 7. So the formula for this kind of question is n equal to 7 and r equal to 5. So n plus r minus 1 c r minus 1. So 7 plus 5 minus 1 c, 5 minus 1. So 12 minus 1, 11 c 4. So 11 c 4. If you find out the 11 c 4, 11 factorial, 4 factorial, 7 factorial, right? 11 minus 4, 7 factorial. So 7 will cancel, right? 8 into, so remaining is 8 into 9 into 10 into 11, and here 4 factorial is 1 into 2 into 3 into 4. So 4 2s are 8, this will be removed, and 3 3s are 9. So 3 10s are 30, 30 into 11, that is equal to 330 is the answer. And the next question is, consider an experimentation of tossing 2 fair dice. Okay, I am tossing 2 dice. Okay, consider this is 1 dice. Okay, this is it having 3, and here 2, 1. Okay, then another 1 more dice. Okay, here you have a dice. 2 fair dice. One is black color. Okay, this is black in color, and this is red in color. What is the probability that the number on the black dice, the number, okay, this number, okay, what is in the black die divides the number on red dice? Okay, so you can also draw in a black. So the number in the black dice should divide the number on the red dice. Okay, so consider 1 will be divided by 1. Okay, 1 will divided by 2. Okay, write down what are the probabilities. It may be 1 comma 1, 1 comma 2. So this is black and this should be red. 1 divided by 1, 2 divided by 1. Okay, and then that is, this black is dividing the red. So 1 is dividing the 2, 1 is dividing the 3. Okay, 1 is dividing the 4, 1 is dividing the 5, 1 is dividing the 6. Okay, the next one is 2, 1 is not divided by, so 2 comma 2, and then 2 is divided the number 4. Okay, and 2 comma 6 will divide. See, understood what I am telling? So this is a red dice. Okay, this is red. Okay, this is red dice value. So 2 comma 2 and 2 comma 4, 2 comma 6. This is in this situation, the black dice is dividing the red dice number. So in the same way, find out 3 comma 3 will come and 3 comma 6 will come. And so totally in your dice you have 6 values, right? So 4 comma 4 will come. Then it won't come, and then 5 comma 5 will come, and then 6 comma 1 2 3 4 5, it won't come anything. So only this, right? Yes. Now you count how many possible events. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Okay, 14 possibilities. So total number of event is 6 into 6, 36. So 14 divided by 36 is the answer. So that is available in the option C. Yes. The next question is, in how many ways can 15 indistinguishable fish be placed into 5 different ponds? Okay, for that what we are doing is 15C5. Okay, but here they ask so that each pond contains at least one fish. Okay, so each pond is already having one fish. So 15 minus 1, C, this minus 1. So 14C4. So 14C4 is nothing but 14 factorial, n factorial. So NC or factorial already explained, n factorial or factorial, n minus or factorial, right? So 14 factorial and divided 4 factorial, 14 minus 4, 10 factorial. So 10 factorial and upper 10 factorial will be cancelled. So 11 into 12 into 13 into 14 divided by 1 into 2 into 3 into 4. Okay, 4 3s are 12. So 12 will be cancelled. This 2 will be cancelled here 7. Okay, 7 11s are 77. 77 into 13, 3 7s are 21. 1, 2, 3 7s are 21, 23, 77. So 1, 10, 0, 1. So 1, 0, 0, 1 is the answer. Option A is the correct answer. The next question is, how many committees of 5 people can be chosen from 20 men? Okay, so 5 people I have to choose from 20 men and 12 women such that each committee contains at least 3 women. So I have to take 3 women. Okay, so what's the woman count is 12. So 12C3. So from the 12 women I have to take 3 women must. So this is one possibility. So that remaining, so I have to take 5 peoples, right? So remaining is 2 peoples are there. So remaining 2 peoples I am taking from the men. So men you have 20. So from 20 I am taking 2 people. So this is one possibility, right? So and then next is, I can also take 12C4 and this is another possibility, right? 20C1. Okay, so and the next one is 12C5. I can also take all the women. So they are not mentioning any you have to take men is compulsory or not like that. So I can also, they are telling that at least you have to take 3 women. So from the 12 women I can also take 5 women and 20C0. So for this you have to calculate 12C3 NCR, similarly NCR formula. Okay, so if you cancel all those things, I will work out and show it. So if we work out NCR formula for 12C3 and 20C2, we will get 41,800 and 12C4 20C1, that is 9,900. Similarly 12C5, that is I am taking 5 women and no men. Okay, so 792. So if you add 52,492. Okay, so total they are asking, see here, how many committees of 5 people can be chosen from 20 men. How many committees you can form with 20 men and 12 women. See here, from the 12 I am taking 3, okay, and from the 20 I am taking 2 men. So and I am seeing what are the possibilities, and from the 12 4 men. So 3 I have taken, right, and then 4 and then 5. So 5 plus 4 9, 9 plus 3 12. So there are 12 women, right? So that's why we are adding all those things. Okay, so that we can able to find out how many the committees we can form from the women. See, we have to remember this also. This 3 plus 4 plus 5, that should be equal to the total number of women. Okay, so option B is the correct answer, 52,592. Okay. The next question is, which of the following statements are false? The first question is, a connected multigraph has an Euler circuit if and only if each of its vertices has even degree. If each of the vertices are having even degree, then it is called as an Eulerian circuit. So this statement is correct. The next statement is, a connected multigraph has an Euler path but not an Euler circuit if and only if it has exactly two vertices of odd degree. So this is also correct. Yes, in a multigraph that is called as an Euler path but not an Euler circuit. If it is an Eulerian circuit, then each of the vertices that should be even degree. Remember, Eulerian circuit, each of the vertices should be even degree. Okay, but in a Eulerian path, if and only if it has exactly two vertices of odd degree. For an Euler path, is any of the two vertices, at least any of the two vertices should be odd degree is acceptable. Okay, in an Euler path, two vertices of odd degree is acceptable. Yes, this statement is also correct. And the next one is, a complete graph has an Hamiltonian circuit whenever n is greater than or equal to 3. So that's also correct. So complete graph is coming whenever you are doing 3 vertices or more than that. And the next one is, a cycle over 6 vertices. So okay, 3, 4, 5, 6. A cycle, okay. A cycle over 6 vertices is not a bipartite graph. We will see. See, here I can shade, here I can shade, and here I can shade. See, 1, 2, 3, 4, 5, 6. So I can bipartite. 2, 4, 6 is one side, and 1, 3, 5 is another set. So we can bipartite this graph. We can bipartite. So this not is correct. So a cycle over 6 vertices can be bipartite graph. But yeah, complete graph over 3 vertices is bipartite. This is correct. But this statement is wrong. A cycle over 6 vertices is able to bipartite. Right? This is able to bipartite. Okay. So their question is, which of the following statement is false statement? So option D is the false. So only D is false, right? So which is available in the option D. The next question is, which of the following is or are not true? The set of negative integers is countable. So if we have a set a equal to -1, -3, -4. So set of negative numbers 1, 2, 3, 4. So how many negative numbers are there? 3 negative numbers are. So it is countable, right? So it is countable, we have to take it. It is a true statement. The set of integers that are multiples of 7 is countable. So that is also countable. 7, 14, 18. So how many multiples of 7? That is also countable. So the statement 2 is also correct. And the third one, the set of even integers is also countable. Set of 7 is countable, then set of 2, 4, 6, 8. So this is also countable. And the set of real numbers between 0 and 1 divided by of 0 divided by of is countable. So here they are telling that the real numbers in between, they are given the they are giving the upper bound. So in between 0 and 1 by 2, there are so many real numbers. Okay, so that will be go in a infinitive. We cannot count that. So option D is the false statement. Okay, so which is available in the D. The set of real numbers between 0 and 1 by 2 is countable. It is not true. Okay. Yes. The next question is, a tree with n vertices is called graceful if its vertices can be labeled with integers 1, 2, up to n, such that absolute value of the difference of the label of adjacent vertices are all different. Which of the following tree are graceful? So first of all, we see what is graceful tree. Caterpillar tree, that is one vertices connected with adjacently one vertex. Okay, this is called as an caterpillar or graceful tree. Okay, graceful means caterpillar or graceful. Okay, when it is from the center, it has only 1 degree. Okay, from the center, so caterpillar tree is called as a graceful tree in which all the vertices are within distance 1 of a central path. So if you see, so wherever you can able to see, there will be a distance of 1 of a central path. So this tree is also an caterpillar, and this is also. So all these options are graceful. So option A, B and C will come under the graceful trees. And the next question, which of the following property group G must hold in order to be an abelian group? Okay, group G. Okay, group itself, which is already told, semigroup, group, monad. So in the group itself, you are having all the qualities such as, what are the group qualities? So the group qualities is, which is already, it consists of associative, identity, inverse and closure property, then only it will be a group. So this group G must hold in order to be an abelian group. If this group has to be an abelian group, then what is the property you have to add? So what is abelian group? In a group you have to add commutative property. If you add commutative property inside the group, then it is called as an abelian group. So only B is correct. So which is available in the option D, B only. There is no need to add distributive or symmetric property. If you add an commutative property, it is called as an abelian group. The next question is, a data cube C has an n dimension and each dimension has exactly p distinct values in the base cuboid. Assume that there are no concept hierarchy associated with the dimension. What is the maximum number of cells possible in the data cube C? So which is, to just a formula we have to remember, p plus 1 to the power of n. P plus 1 to the power of n. And the next question is, suppose that from given statistic it is known that meningitis causes stiff neck 50% of the time. That the proportion of person having meningitis is 1 by 50,000 and the proportion of people having stiff neck 1 by 20. Then the percentage of people who have meningitis and complain about the stiff neck. Okay, so this is a probability of B divided by A. Probability of B divided by A is probability of A divided by B into probability of B. Okay, so divided by probability of A, right? So here in this you have to apply here. Meningitis causes stiff neck. Okay, meningitis causes stiff neck 50% of the time. Consider this one is meningitis and this one is stiff neck. A is meningitis. Okay, so probability of M is meningitis. Okay, and S is stiff neck. Okay, meningitis causes stiff neck, that is 50% of the time. That the proportion of person having meningitis is 1 by 50,000. Okay, probability of A because of B. Okay, and probability of B, proportion of people having stiff neck. Okay, this is B. Okay, stiff neck is B. M is A. Okay, consider this. So stiffening is 1 by 20. Okay, this is upper part, and probability of A is 1 by 50%. So that is 50 divided by 100 equal to 1 by 2. Okay, 50% can be written as, this is Menning's causes, that is probability of A. This is proportion of people stiffening 1 by 20. Okay, so 50% can be written as 1 by 2. Okay, so if you cancel, if you cancel, what will you get? 1 by 5, 1, 2, 3, 4. So this 2 will be cancelled, right? So then this 1 by 20, right? So this 20, this will be cancelled. So sorry, just a minute. Okay, just a minute. I'll explain. See, A is Menning's, B is stiffening. Okay, so here Menning's causes stiffening. Menning's causes stiffening. That is nothing but probability of A divided by B, probability of M of S. That is 50% of time. That is 1 by 2. This A by B is 1 by 2. Okay. The next one is that the proportion of person having Menning's. Okay. Proportion of person having Menning's is M. That is 1 by 50,000. Okay. That the proportion of people having stiffening. Proportion of people having stiffening is this 1 by 20. Okay, this is probability of A and this probability of B. Okay, so if you cancel this 0 will be cancelled. 1 by 5 equal to 0. 1 by 5 equal to 0.2. So 0, 0, how many 0? 3, 0, 2. So if you give in a percentage, wise 0.02 percentage, multiply by 100, divided by 100. Okay, so option B is the correct answer. So this is the formula, probability of B divided by A equal to probability of A divided by B, probability of B, probability of A. Okay, this is an Bayesian theorem. Okay, just check it out. Okay, check it out and work out slowly. The next question is, consider the graph given below the two distinct set of vertices which make the graph bifurcate. So which make the graph bifurcate. So to identify the bifurcate, what I told, first you take a node in one color. Okay, first you take the node in one color. Okay, take whatever the connected, what are the the vertex V1 is connected with another vertex. So V3 is another set. Okay, V5 must be in another set and V2 must be another set. Okay, and now, okay, again you take V2 and give the another color. Okay, give another color. So I am giving, so this is another set. So I am giving red. So this should not intersect. So this is blue and this is, and here, so blue and blue. So V7 should be red. Okay, so V8 should be blue and V5 and V2 is connected with V6, that should be red, and this should be blue, right? So now you see what is the one set. So blue and all one set, red and all will be one set. So V1, V6, V4, V7 is one set. Okay, and blue color V2, V5, V3, V8 is another set. So which is available in the option C. Okay, V1, V5, V4, V6, V7 is one set, and V2, V3, V5, V8 is another set. The next question is, a clique in a simple undirected graph is a complete subgraph that is not contained. Actually, this won't come. In any larger complete subgraph, how many cliques are there in the graph? Actually, this question is like this. Okay. So, how many cliques are there? So this is one clique. Okay. So, this you can bypass it. That is, you can split it. This is 1, 2 and 3 and 4 and 5. Okay. So, this is clique. So, 5 is possible. So, 1 I can split like this, or I can split like this, or I can split like this and split like this. So, this is called cliques. That is, we cannot split further. This is called complete subgraph. Okay, any larger complete subgraph. So, this part you cannot split again. Okay, this is clique. So, option C is the correct answer. Yes. The next question is, how many different equivalence relation with exactly 3 different equivalence classes? Okay, there are 3 different equivalent classes are there on a set with 5 elements. So, totally 5 elements. How I can split into 3 different equivalent classes? Okay, so I can split 3, 1, 1, or I can split this into 2, 2, 1. Okay, so this is 1 and this is 1 type. Okay, if I split this, so first 3. Okay, from the 5 elements I am splitting into 3 elements, that is equal to 5C3. And then how many elements are remaining? 2. Okay, so from that 2 elements I have to choose 1. Okay, so 2C1 and remaining element is 1. So 1C1. Okay, so this you have to multiply. So 5C3 and this should be divided by 2 factorial. So similarly, this 2, 2, 1. Okay, that means 5 elements. I am choosing 2 elements and the remaining is 3 elements. So from the 3 elements I am taking 2 elements. So 3C2. Okay, and the remaining is only 1 element. So 1C1. So that should be divided by 2 factorial. So this is the we have to calculate. So if we calculate, you will get 5C3 means n factorial or factorial. So 5 factorial, 3 factorial, 2 factorial. So 3 factorial will cancel. That is 4 into 5 divided by 2, that is equal to 10. So here 2C1 equal to 2. So and then so 10 into 2, this is 1. 1C1 equal to 1. So divided by 2 factorial. 2 factorial is 2. So this 2 and this 2 will be cancelled. You will get 10 here. Okay. Similarly, if you calculate this 5C2, what 5C2 is? So 5 factorial divided by 3 factorial, 2 factorial. So 3 factorial cancel. 4 into 5 divided by 2. So that will be given 10. Okay. So 10 into 3C2 is, so 3 factorial or factorial, 1 factorial. So 2 cancel, 3 will come, right? So 1C1 is 1. So divided by 2. So if we cancel 2 5s are 10, 5 3s are 15. So 10 plus 5, that is equal to 25. The answer is option C, 25. Okay. The next question is, the number of different spanning tree in a complete graph K4 and bifurcate graph K2, 2 have dash and dash respectively. So the number of spanning tree formula is, so if you want to find out number of spanning tree, the formula is n to the power of n minus 2. So 4 to the power of 4 minus 2, that is equal to 4 square, that is equal to 16 spanning tree. Okay, number of different spanning trees in a complete graph K4 and bifurcate graph K2, 2. So 2, 2 is, that is n is 2. Okay, sorry, in a bifurcate graph we have to m into n. Okay, so this is 2, 2, 2 into 2 equal to 4. So 16, 4 is the answer. The next one is, suppose that R1 and R2 are reflexive. So R1 and R2 are reflexive. Consider this R1 as 1, 1 and 2, 2, and R2 is 2, 2 and 3, 3. Okay. So these are all reflexive relation on a set A. Which of the following statement is correct? So surely this will also be union. Okay. Because if you have a set equal to 1, 2, 3, then surely if R1 is the reflexive relation of this set A, okay, this will also contain 3, 3 and this will also contain 1, 1. So if R1 contains reflexive relation, if R2 contains reflexive relation, then we can say that R1 union R2 is also reflexive and R1 intersection R2, that is also an reflexive relation. So which option will come? R1 intersection and R2 is reflexive, and both, okay, both R1 intersection R2 and R1 union R2 are reflexive. Okay. The next question is, there are 3 chords in a box. Both sides of one chord are black. So both sides of one chord is black. Okay, consider this is one chord. Okay, the both side, this side and the back side is black. Okay, both sides of one chord is red. Okay, consider the another chord. This one is red and the back is also red color. And the third chord has one black side, one black, in the opposite side it is red. Okay, so in the third chord has one black side and one red side. We pick a chord at random and observe only one side. We pick a chord from the 3 chord. I am picking one chord. Okay, so total number of event is 3. So from the 3 chord I am picking one chord. What is the probability that the opposite side is the same color as the one side we observed? So if I am taking a particular chord, that the front side is also same and the back side is also same. So how many chords are there? Front and back is same. So black here, front is also black and another back is also black, and here red chord is there. So there are, from the 3 chords I have 2 possibilities. Okay, so the option is B, 2 by 3 is the answer. The next question is, consider a sequence F00 defined as. So F00 of 0 is 1, F00 of 1 equal to 1. Okay, they are asking f of n, this is when n is greater than or equal to 2, right? So I have to find out this f of 2. You no need to remove the zeros, just for to confuse us, they are giving like this. So f of 2 equal to 10 into f of n minus 1. 2 minus 1 is 1 plus 100 divided by f of n minus 2. F of here n is 2. So 2 minus 2 is 0. Okay. So again they given the value f of 1 is 1. Okay. So 100, f of 0 is 1. So 100, this is 10 plus 100. So and 10. Okay. The first value is 1. Okay. F of 1 is 1. Okay. F of 1 equal to 1. F of 2 equal to 1, 1, 10. So now I have to find out f of 3 value. F of 3 equal to, apply in this f of n equation. So you will get 10 into f of n minus 1, that is 3 minus 1, that is equal to 2 plus 100 divided by f of 3 minus 2 equal to 1. So what is f of 2? We calculated here 110, right? So 10 into 110 plus 100. Okay. Then f of 1 value is 1. So 110 is, that is equal to 1100 plus 100. So you will get 1200. Okay. So 10 into 110 plus 100, you will get 1200. So f of 3 value is 1200. So 1, 110, 1200 is the set of sequence of value in this f of function. Okay. The next question is that match the following. Absurd. Absurd means clearly impossible, being contrary to some evident truth. Okay, this impossible being contrary to some evident truth. Ambiguous means, unambiguous means very clear. Ambiguous means it is some confusion, more than one interpretation, more than one meaning. That is called ambiguous. Unambiguous means it is very, very clear. Okay, so ambiguous means capable of more than one interpretation or meaning. So this one is the second one. The next one is axiom. Axiom is nothing but an assertion that is accepted and used without a proof. Okay, axiom means normally in a thesis and all they will do assertions, right? So I am taking a particular equation. According to me, I thought that A plus B equal to C. Okay, I am taking my assertion is I am taking that and accepted, and I am doing the project on that basis. So that is called as an axiom. Axiom is an assertion that is accepted and used without a proof. So that is the third one. The next one is conjecture. Conjecture is an opinion preferably based on some experience. Based on some experience I am doing. Okay, so that is called conjecture. Okay, so which is available in the option A. Absurd means clearly impossible, being contrary to some evident. Ambiguous means capable of more than one interpretation. Axiom means an assertion that is accepted and used without a proof. And then conjecture, an opinion preferably based on some experience or wisdom. The next question is, this function mapping R into R are defined as. So the next question is, the function mapping R into R defined as f of x equal to this and g of x is 1 divided by x squared plus 1 and h of x is equal to x power 4. Then find the value of the following composite function h of gx. Okay, first I have to find out h of gx. So what is g of x? That is 1 divided by x squared plus. This I have to apply in the h of x. What is h of x? X power 4. Okay. In this x power 4, I have to apply g of x. So what is g of x? 1 divided by x square plus 1 so x. So I am assigning x value. Okay. So to the power of 4, x power 4. So what will you get? 1 to the power of 4, that is 1 only. So x square plus 1 to the power of 4. So if you take this x square plus 1 in the upper, you will get x square plus 1 minus 4. Okay, so h of gx, this one is x square minus plus 1 to the power of minus 4. So similarly, if we want to find out h of g of x, h of g of f of x. Okay, so first I have to find out the g of f of x. So g of f of x. So what is g? G is 1 divided by x square plus 1. In this place of x, I have to assign f of x. So what is f of x? X cube minus 4x, x cube minus 4x the whole square. Okay, x cube minus 4x the whole square is the answer. So plus 1. So this is my g of f of x, right? So g of f of x. Now this I have to apply to the h of x. So what is h of x? Is nothing to the x power 4. So to the power of 4 will come. Okay. So this is x means I have to apply this x to the power of 4 because this is x of 4. H of x equal to x to the power of 4. So now this is x. Okay. So what happened? So x cube minus 4x square x cube minus 4x the whole square plus 1. Here it is 4, right? So if you take upper it will be minus 4. Okay, 1 to the power of 4, 1. So option D is the correct answer. The next question is, how many multiples of 6 are there between the following pair of numbers, 0 and 100? So 0 and 100, how many multiples are there? So 100 divided by 6, 1 6 are 6 and 4 6 6 are 36. 16 plus, but 0 is also here, it will count from 1 6 or 6, 2 6 or 12. So 0, if you 0 6 or 0, right? 0 into 6 equal to 6. So 0 will also come. Okay. So 16 plus 1 is 17. In between 0 and 100, how many multiples of there? Multiples of 6 are there? That is 17. And minus 6 and 34. Minus 6 and 34, how many numbers are there? So minus 6 to 34, how many numbers? So minus 6 is 1 and 0 is 1 and 6, 12, 18, okay, 24, 30, 7 6 are 32. So 1, 2, 3, 4, 5, 6, 7. So 7 multiples are there, and in this pair 0 and 100, 17 is there. So 17 and 7, option C is the correct answer. The next question is, consider the Hamiltonian graph with no loops or parallel edges and V of g equal to n is greater than or equal to 3. Then which of the following is true? Degree of vertices is greater than or equal to n divided by 2. Degree of vertices is greater than or equal to n divided by 2 for each vertex v. So this is one rule for Hamiltonian graph. And the next one is, edges of this graph is greater than 1 divided by 2 into n minus 1 into n minus 2 plus 2. So this is also correct. And degree of vertices and degree of w should be greater than or equal to n whenever v and w are not connected by an edge. So this is also a rule. So all the above is the answer. The next question is, which of the following respectively represent the commutative law, associative law and distributive law? So what is commutative law? A plus b equal to b plus a. If I represent like this, this is called commutative law. So which is available in the option 3. Okay. So 3 is a commutative law. Okay. And the next one is associative law. So if I a dot b dot c, if I give the bracket here, okay, a dot b dot c, okay, this is called associative law. This associative law is present in number 1. And next one is distributive law. Distributive law is a dot b plus c, that can be written as a dot b plus a dot c, right? So this is 2. 3, 1 and 2 is the answer. So which is available in the option D. Okay, 3 is a commutative law and 1 is a associative law and 2 is a distributive law. The next question is simplified form of the Boolean expression. So simplified form of this Boolean expression, first we have to multiply this x dot x plus x dot z, okay, then y dot x, okay, y dot z, and this xy dot x plus x y z. Okay, see in this place x dot x can be written as x. Okay, when you take x outside, 1 plus z plus y plus xy plus and here yz. So whatever is added with 1, the result is 1. Okay, so whatever 1 is present means 1 plus z equal to 1, 1 plus z plus y plus whatever it is, the voltage will be always power on. So whatever the line is coming, there is no issues. Okay, so 1 plus any variable, that is the answer is 1. So and then yz is the answer. So x plus x dot 1 equal to x. So x plus yz is the answer, which is available in the option C. The next question is the number of canonical expressions that can be developed over a 3-valued Boolean algebra. 3-valued Boolean algebra means x, y, z. So if there are 3 variables, how many you can represent? 2 power 3 equal to 8. So if there are 8 things can represent. So canonical expression is 2 to the power of 8, that is 256, which is available in the option D. Okay. The next question is which of the following is true. So you just multiply and see a dot a plus a dot c plus b dot a plus b dot c. If you multiply, what will get? A equal to 1, right? So if you take a dot a equal to a, so you will get 1 plus c plus b. So 1 plus c plus b, that is equal to 1 only, plus b dot c. And so the answer is a plus b c. So a plus b c, which is available in the option C. A plus b into a plus c, that is equal to a plus b c. And the next question is what is the form of the Boolean expression ab plus b bar c bar equal to y. So which is in the which format? Either it is SOP or POS, sum of product. So this is product. Okay, this is product and this is sum. Okay, this you can call it as SOP. So option B, which is in the which format? This is in the SOP format, sum of product. The next question is the minimum number of edges in a connected cyclic graph of n vertices. They are asking minimum number of edges. Okay, if there is 3 vertices and the 2 edges are enough to connect the graph. Minimum number of edges. If they ask maximum number of edges or complete graph, then only n into n plus 1 divided by 2. They are asking minimum number of edges in a connected cyclic graph. Remember, they are asking cyclic graph. So if there is a cycle of n vertices, 3 vertices means I need 3 edges, right? So n vertices. So here 3 vertices. So to represent a cyclic graph, I need 3 edges, right? So if there are n vertices, I need n edges to provide a connected cyclic graph. See, if there are 4 vertices, if I want to provide a cycle, 4 edges are required. If I have a 5 vertices, I need 5 edges to make it as a connected cyclic graph, right? Yes. The next question is the number of distinct simple graph with up to 3 nodes. Number of distinct simple graph with up to 3 nodes is 2 power n minus 1. So that is equal to 2 power 3 minus 1, that is equal to 8 minus 1, that is equal to 7, which is available in the option C. The next question is, in any undirected graph, the sum of degree of all the nodes is twice the, so this is nothing but an Handshaking theorem, which is already saying sum of degree of all the vertices equal to 2 into edges, that is twice the number of edges, that is available in the option B. Is any undirected graph, the sum of degree of all the nodes is twice the number of edges. The next question is a graph in which all nodes are of equal of degree is called as regular graph. In a particular graph, if all the nodes have, see, if all the nodes have 2 degree, this also have a 2 degree and this one is also a 2 degree and this one, so this is called as regular graph. This is called as regular graph. In a graph which all nodes are all of equal of degree. Okay. The next question is, 2 isomorphic graph must have same number of vertices, same number of edges and equal number of vertices. So all the above is this. So if this, see here the same graph can be represented in any form. Okay, so like this or like this or something, so whatever it is. Okay, so if you find out Okay, so if you find, remove this. Okay, so these two these two graphs are isomorphic. Because number of vertices is same and number of edges is also same, equal number of vertices and the cycle length is also same. Okay. The next question is, for each integer n is greater than or equal to 0, 5n minus 1 is divisible by 5n minus. So first you put 1 for n. So 5 minus 1 equal to 4. So 4 is divisible by 4 or 6 or 14 or 3. So 6 won't divisible, 14 won't divisible. So up to given option 4 is the divisible. And the next question is, a box contains 12 socks of white color and 12 socks of black color, all unmatched. A man takes socks out at random in dark. How many minimum socks must be taken out to be sure that is at least 2 socks of the same color? Okay, so there are 12 socks of white and 12 socks of black color. If I want to take, you must take at least 2 socks. Yes, at least 2 socks of the same color. See, so if I want 2 socks to be same color, right? 2 socks. So if I take 3, okay, here see, I'm from here 12 socks of white color. Here I am taking 1, and black, first time I am taking white color, and second time I am taking black color. If I take again, what will happen? It may be either white or it may be either black. So from 3, if I take 3 socks, surely I will have a at least I have a 1 matching color. Okay. So at least I have 2 socks of the same color if I take only 3 socks. The next question is, suppose the same kind of question. Suppose 6 pair, very careful in this 6 pair, there it is, they may also ask 6. Okay, so here 6 pair of similar looking boots are thrown in a pile. So in a bag you have, okay, in a bag you have 6 pair of shoes. Okay, 1, 2, 3, 6 pair of shoes. 4, 5 and 6. Okay. How many boots must have pick in order to be sure of getting a matched pair? So if I want to get a matched pair, see, that is different from this. Here they are asking, I have to get a matched pair. So this is 6 different types of boots. Okay, so 6 times I am getting a different boots. Plus if I take another one, surely 1 boot will be matched with this, right? 1 boot will be matched with this 6 pair, any one of this 6 pair. So 6 plus 1. So if I take 7 boots, I will surely be 1 boot will be matched pair. Okay. Yes. The next question is, indicate which of the following well-formed formulae are valid. In this, we have to draw a truth table and verify it. Just B and Q. Okay, negation P and Q. So that implies P implies Q. For example, I am writing only 1. For P implies Q, value for P implies Q is negation P or Q, right? So 0, 0, 0, 0, 1 and 1, 0, 1, 1. Negation P is 0, 0. Q is 1, Q is 0. So this I need, right? So negation P R Q, that is negation P 0 or 1, that is equal to 1. Here 1 or 1, that is equal to 1. 0, 0, 0, 1. So this is the answer, right? So you have to similarly you have to find out negation P or Q and Q or that you have to check with P implies or. Okay, if you find out, the answer is option B. Okay, the answer is option B. Kindly check it out. The next question is, in proportional logic, which of the following is equivalent to P implies Q? So if I told already, P implies Q means it's nothing but negation PR Q. So here it is negation. So it is available in the option B. Okay. The next last question. So this one is, convert the set X in roster form. Is set X contains a set of positive prime number which divides 72. They are telling that this set X contains set of positive prime number. So null won't be there. They said that it's a positive prime. So which divides 72. So 2 is divided, the 72 divided by 2 equal to 36, right? So 2 will come in the set. 72 divided by 3 equal to 2 3s are 6, 4 3s are 6. So 3 is also divisible. Divide the 72. So 3 will come in the set. So 72 divided by 7 is divisible? No. Okay. So 7 won't come. 5 also won't come. So x equal to 2, 3 is the answer. Yes friends, we successfully completed all the 100 question and discrete structures. All the best. Go ahead and achieve your dreams. Thank you so much.